National High School, Davao City Division, Teleradio Broadcasting. Good morning to our dear grade 10 students. I'm so glad that you have tuned in to your favorite channel, airing this teleradio-based instruction in science. I know that you're so excited listening on this episode entitled Geologic Processes and Landforms Along Plate Boundaries with Ma'am M.R. Forones Salvar as your teacher broadcaster. As you carefully listen and understand what the topic is all about, you get to learn something meaningful and important science concepts and ideas, and even discover some important facts through self-explorations. Today, you are going to learn on the different geologic processes and landforms along plate boundaries. So, sit back and relax as you view some slides that would help you visualize some natural processes occurring along plate boundaries, which could bring about different land formations. Are you ready now? Say yes, yes, yes! That's great! Okay, at this moment in time, let's take a look at your science module in Quarter 1, Module 3. Does anyone got the idea about the topic? Yes? Can you share your idea with us? Great! Happy to note that you have gone for that much about the topic. Alright, before we start our lesson proper, maybe some of you have personal necessities. You may attend to it now in 1 minute time.
A few moments later.
Okay, you may now settle down and watch the advertisement. After this, we shall have our topic 1 discussion. Are you ready, class? Here we go! Our topic today is about explaining the different processes that occur along plate boundaries, which is based on the most essential learning competency of the Department of Education. Based on the topic given, the lesson is divided into 3 categories. First, you are going to identify the different geologic processes that happen along plate boundaries between convergent plates, namely oceanic plate and oceanic plate collision, B. Oceanic plate and continental plate collision, C. Continental and continental plate collision, and you've got to explain the effects of these processes on lithosphere. Secondly, you still have to identify the different processes that are taking place along plates between divergent boundaries, where and why they take place, and their effects. On transform fault boundary, also known as strike-slip boundary, will be described further by its example, the formation of famous San Andreas Fault. This time, try to look at Module 3. Previously, you have learned that the convection current on the Earth's mantle have caused too much pressure on crust, which results to the breakage of lithosphere into smaller segments. In effect, spaces in between or plate boundaries are created. These plate boundaries are named according to the relative movement of the plates with each other. Do you still remember the 3 types of plate boundaries? Great! Can you still recall our lesson on convergence of plates? You've learned that the convergence or collision of plates could happen between oceanic and continental plates, also between oceanic and oceanic plates, and between 2 continental plates. Let's try to carefully observe and discover how each type of convergence of plates could result to different landforms and geologic processes. Look at your Module 3 activity number 1 on page 5 entitled Convergence between an oceanic plate and a continental plate. You have 5 minutes to perform it and make sure to explain the processes that occurs between plates.
5 minutes later.
Are you done? Time is up! Congratulations! You've done it well! Have you enjoyed it? Let's learn more of convergence of plates. Students, you have learned that when an oceanic crust converges with a continental crust, a crack between the crust and underwater called trench is formed. Why? Because the oceanic crust is denser than continental crust due to the presence of water on it, making its density greater. This causes the oceanic crust to dive down or subduct under the overriding plate, the continental plate. The process is called subduction, in which a plate dives under a less dense plate. At the mantle, the leading edge of the subducting plate melts or becomes fluid. It turns into a hot molten material, which we call magma. Due to the increased heat in the mantle, the magma builds up a pressure that enables it to push the ground above it. This creates a column of rising magma called a mantle block. When there is volcanic activity such as eruption, the ground moves, which is felt by us as an earthquake. As subduction of plates continues, the magma keeps pushing up between the cracks, forming a group of volcanoes called volcanic arc. The continued movement of the ground may cause a disturbance in the ocean. This may cause the water to flip or kick upwards to a few meters high called tsunamis, a Japanese term for harbor wave. This event is very dangerous when it moves inland, destroying lives and properties. Moving on, let's make it more exciting. Let's see if you can do this way. This time, you will be given a chance to discover geologic processes which may happen between the convergence of oceanic plates. Okay, let's have identified the geologic processes and events that occur whenever two oceanic plates converge or collide. Let us perform activity 2, page 6, convergence between two oceanic crusts. You have 5-minute time to do it.
5 minutes later.
Are you done? Congratulations, you made it right. Okay, let's learn more about it. The convergence of two oceanic crusts result in some similar events compared to the first type of convergence. Tsunamis may be formed, earthquakes may happen. There is also subduction because one plate is denser than the other. The front part of the subducting plate becomes magma upon reaching the mantle. Then, it builds up pressure due to heat, pushes the crust above it, forming a volcano. This is a continuous process. Since the plates are moving away from the mantle, the volcano will move with the plate and the volcano becomes extinct. A new volcano will then be formed just above the mantle plumb. As the plate continuously moves, this volcano is then rafted away, forming a series of volcanoes called volcanic island arcs surrounded by water. Do you know why the Philippine plate is mostly loaded with volcanoes? This explains that the different islands were believed to have originated from the convergence of two oceanic crusts. Good job! You are now on the next level of learning. Let us perform Activity 3, page 7, Convergence between two continental crusts.
A few minutes later.
Are you done? What have you observed? What makes this type of convergence different from the other types of convergence of plates? Great! You are now very good in identifying and describing some geologic processes that take place in convergence between two continental crests. Now, let us discuss further. In converging continental crests, what are the processes that occur? Converging continental crests or plates result in a collision zone which could cause shallow earthquakes. At that place, a crack called fault is formed. This type of convergence will cause no subduction. Why? Because the two plates have the same densities. There would be no volcanoes formed, no tsunamis. The convergence will result in a group of high landforms that we call mountain ranges. One example of this converging of two continental crests is the collision of Indian Plate and Eurasian Plate, creating the Himalayas Mountains. Before we proceed to our lesson 2, let us summarize now the different geologic processes and events that occur in every type of convergence of plates. When oceanic crust converges with continental crust, these are the geologic events: formation of volcanic arc, formation of trench, occurrence of tsunami, earthquake, and subduction of plates. For the convergence of two oceanic crests, occurrence of tsunami, earthquake, subduction of plates, and formation of volcanic island arc. And in the converging of continental crests, there is a shallow earthquake, formation of fault, formation of mountain ranges, no subduction process, no volcanic formation, and no tsunamis. After learning something from Lesson 1, let us now proceed to Lesson 2, which is the processes and landforms along divergent boundary. Could you still recall what divergent plate boundary is? Yes, you're right. Divergent plate boundaries mostly happen under the oceans. As plates pull away from each other, a vertical space may extend deep down in the lowest layer of the crust is created. It is a rift valley. The force of separation creates a tension zone. A shallow earthquake may happen with this plate movement. Plate divergence is believed to be a slow, continuous process. As the plates move away, the gap between them increases. While this happens, materials from the mantle may rise, filling up the space. These materials pile up near the tension zone, forming a mountain-like structures called oceanic ridges. But new materials from the mantle may push the old ones. The filled-up space between the plates becomes a new seafloor. The process is known as seafloor spreading. Have you tried eating a half-cooked egg? As you cut and open the white part with your spoon, what comes out of the cooked part? Yes, it is the half-cooked egg yolk. The divergence of plates is somewhat similar to splitting open egg. As it opens, the half-cooked egg yolk gradually flows out. When it cools down, it becomes solid. Before moving on to Lesson 3, let us have a short recap on the different landforms produced on divergent plate boundary. Could you still remember what geologic events or land formations take place whenever divergent plate boundaries split off with each other? One is formation of rift valleys and oceanic ridges. There is occurrence of shallow earthquake and widening of ocean basin after long years. Let us proceed now to Lesson 3 after acquiring so much information and knowledge on Lesson 1 and 2. The next type of plate boundary is what everyone fears about these days. It is the transform fault boundary. With this type of boundary, another geologic feature is formed and events happen. In the transform fault, where plates slide past one another without the creation or destruction of crust, because rocks are cut and displaced by movement in opposite directions, rocks facing each other on two sides of the fault are typically of different types and age. These structures are so-called strike-slip faults. When strike-slip movement halts due to increased friction at some location, stresses can build up that are released in sudden slips. This may result in some of the most damaging earthquakes on continental crust. The San Andreas Fault in California, USA is an example of huge strike-slip faults transecting continental crust. Did you get it right? We're done with our lesson today on the different geologic processes and landforms along plate boundaries. Have you learned something meaningful today? Let me check if you could still recall. In the convergence between oceanic plate and continental plate, why does oceanic plate subduct over a continental plate? Anyone who could answer this? You've given a correct answer. For your assignment, kindly read and answer additional activity. You can find that on page 18 of your module and submit your output to your teacher. If you have some queries or point for clarifications, please don't hesitate to contact your science teacher. Congratulations! You've done a great job, for you've learned something meaningful and useful to your life today. Hoping that you could apply what you've learned in your day-to-day life. In tomorrow's lesson, we will be tackling about Earth's mechanism and have an advanced reading about it. Once again, I am your teleradio program broadcaster, Emar Forones Alvar, saying, never stop learning because life never stops teaching. Goodbye, students, till we meet again. Have a blessed day, everyone. Bye-bye.